Good morning. I hope everybody is doing well. So today's warm-up is a review of something from a long time ago. So let's see how we did. Number one, what did you get? We've got students. Well, thank you for the volunteers, but I'm going to go with the equity bars. And students 5, 20, and 7. Student number 5, what did you get? Student number 20, what did you get? Student number 7, what did you get? So 3 of my students think that the answer is negative 100, and it is. Number 2, what did you get? I've got students 24, 21, and 4. Student number 24, what did you get? Okay, student number 21, what did you get? Okay, and student number 4, what did you get? So the correct answer is 48 over 49. So these questions have something in common, that they involve exponents. And you will also start hearing today the term power. That is also referring to the same thing. This is referred to as a power. This is referred to as a power. So that leads us into today. But before we get into that, does anyone have any questions on the warm-ups? Cheyenne.
When the power is like, is there only 3 ways to say like 2? It's like 2 squared and 2 cubed. Is there any other way that you can go by saying by the other numbers?
I'm not sure, but those are definitely the most common ones. So yes. X to the second power is also called x squared, and x to the third power is called x cubed, and we talked last time about why it's a square, and we talked about things like that. Okay? Yes, Kayla.
Why is it that when you put -7 squared into the calculator, it comes out as -49? Yeah.
Because it depends on how you put it, and it depends what kind of calculator you have. You have a scientific calculator, you need to put an open parentheses, a -7, close parentheses, and then the square. If you have a very basic calculator, it won't let you do that. There is actually a difference between this, and I'm not going to get into the difference right now. It is something that you will explore later on. But there is actually a difference between these two things. This actually equals 49, and this actually equals -49. But for our purposes, for what we're going to be studying, we're just going to be dealing with this. Okay? Very good question. Any other comments, questions? Any concerns of any kind? Okay? Today's lesson is lesson 6-1, part 1. Make sure you write part 1. Today's part 1 will be all-inclusive, meaning the homework assignment will only be for part 1. So today's lesson, yes, there's going to be a second part because it's directly related to what we do today. However, it's going to be graded by itself. So you're going to get a grade for 6-1 part 1, and you're going to get a separate grade for 6-1 part 2. You will understand why when we finish part 2. And we're going to start exploring properties of powers. And I had given you a heads up the other day that what we're going to be studying is going to get pretty challenging. One of the aspects that is very challenging, Michael, is the fact that there's so many different things to remember, and they all sound similar, and they all function in a similar way. And one of your jobs is to start being able to keep it straight. I'm telling you right now, there's going to be moments today where you're confused, where you can't tell the difference between one thing and another. Sometimes when we get confused, we get a little nervous, we get a little scared, we get a little frustrated. That's understandable. But what is not okay is to then say, I can't do it. What is not okay is to then say, forget it. That's not an option in my room. So make sure that this word, perseverance, is really playing around in your mind as we go through today's lesson. Any comments or questions so far? So today we're going to focus on multiplication properties of exponents. There are 3 properties that you are going to learn today. We're going to explore them independently, and then we're going to be working on them all at the same time. The real hard part comes when we have to use them all at the same time. So, the first property is called the product of powers property. 3 words that have letter P at the beginning. Product of powers property. What does product refer to? What's a product? Got 4 people who know the word product. Alex, what's a product? Wow, you said that so phenomenally well, because a lot of people miss the answer to part. That was great. Answer to a multiplication problem. So when you say product of powers, we're talking about multiplication of powers. So, what I'm teaching you today is a shortcut. You don't even know the long way to do it yet, and I'm already teaching you a shortcut. That's a little backwards, but you're going to see why this makes sense in a few minutes. To multiply powers that have the same base, you add the exponents. So there are key words. Multiply, same base, add. Multiplying powers that have the same base, you add the exponents. So, here is what I'm talking about. In a very generic sense, a very broad overview. A to the m times a to the n equals a to the m plus n. That's like speaking a foreign language, but it actually makes perfect sense. So here are the phrases that the words or phrases that I highlighted. Multiply, multiply. Same base, this is the base. Remember, the base is the big number. And then add the exponents, that's right there. Multiply, same base, add the exponents. So here's a more practical example. 5 to the 3rd power times 5 to the 5th power equals 5 to the 8th power. Let's do a test to see if that's true. So I'm going to give you a quick calculator assignment. Pick up your calculator, and everyone in this group right here, everyone in these columns, you are going to do 5 to the 3rd power in your calculator. You do 5 times 5 times 5. Everybody in this column is going to do 5 to the 5th power. 5 times 5 times 5 times 5 times 5. Go ahead and do that now. So, what does it come out to, Marcus? Okay, so 5 to the 3rd power is 125. And what is 5 to the 5th power? I need a volunteer over here. Yadesh? 3,000, what is it? 3,125, is that right? Okay, and we're multiplying them together. So now everyone pick up your calculator. Everybody in the room is going to do the same calculation. Everybody do 125 times 3,125. Do that right now. Keep that number in your calculator. Do not erase your calculator. Everyone keep it and looking at the calculator and looking up here. Look at your calculator, look up here. Looking at your calculator and look up here. In my calculator, I have 5 to the 8th power. 5 times 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 5. Does it come out the same as what you got? Yes. Okay, so we just proved by doing the simplification of 5 to the 3rd, 5 to the 5th, multiply those two together, we get the same value as 5 to the 8th. So we just proved that this works. Does anyone have any questions about that? Yes. I can't hear anything you're saying. Okay? All right, I'll come see what you're talking about in a moment. All right, so let's show this another way. So now, showing you a different way. So what I have here is I have expanded this. 5 to the third power becomes 5 times 5 times 5. Of course it is. That's what it is. And now 5 to the fifth power becomes 5 times 5 times 5 times 5 times 5. Now, how do you write that as a power? I mean, I already had the answer there. But how do you write this? How did I get 5 to the 8th power? Let me hide the rest so you can focus where I want you to focus. Forget about the rest. How do I get this? Where did it come from? This is one of those moments where everyone's hands are frantically waving because it's so clear. Okay, Chopin? So you have to speak a little more clearly. I'm sorry. You add how many 5s there are? How many 5s are there? You sure? Did you count them? So there's 1, 2, 3, 4, 5, 6, 7, 8 5s here. And that's what an exponent is. An exponent tells you how many of a number are being used in the multiplication problem. And so if we expand this to its expanded form, then we can count them and we get this answer. But now we don't need to do that anymore because now we have this shortcut that gets us the same result without having to do that. So the whole point of this property is to eliminate the need to do this. We now don't need to do that anymore because we are able to take a shortcut. Does anyone have any questions about that? Any concerns? So that's called the product of powers property. So now let me mess you up. Now we're going to do the power of a power property. This is my favorite property of all time, of all the math and scientific properties in the world. Power of a power is my favorite. I know it's very strange to have a favorite property, but I do. Because it sounds so powerful. Power of a power. It's the power of a power property. It's pretty powerful. And so, power of a power says to find the power of a power, you multiply the exponents. So, unfortunately, here's the bad news. You've learned two properties, or you've seen two properties, and they both have words with the letter P at the beginning, 3 of them. The first one said product of a power, property. This one says power of a power, property. It's an awful lot of P words. And they all deal with powers. And one of them you add the exponents, and one of them you multiply. So guess what? One of your jobs is to keep it straight. So with power of a power, you multiply the exponents. So what do I mean, power of a power? This is what I mean. This is a power, and it's being brought to another power. The parentheses is the key. So if you have power of a power, you multiply the powers together. Here's a concrete example. 5 to the third power to the fourth power will equal 5 to the 12th. This one's a little harder to prove because if you have a 5-function calculator and you try to do 5 to the 12th power, probably won't be able to handle it. So I'm not going to do that in this case. We're going to look at it expanded. So here is what 5 to the third power to the fourth power really means. Okay? So let me clarify. What if I took out the 5 to the third power, and I just put an x. I just put an x right there. How would I say x to the fourth power? What would that be written out? X to the fourth power. Chanel?
X times itself 4 times.
So go ahead, say the whole thing.
X times X times X times X.
Okay. So x to the fourth power would be x times x times x times x. So what she just demonstrated was whatever is in here, we have to say 4 times, right? So let me change it. What if I put a letter H to the fourth power? What would you say now? Adriana?
H times H times H times H.
So you have to say it 4 times, right? No matter what's in there, you have to say 4 times. So now let me show you what's really in there. How many times do you have to say 5 to the third power? 4 times. So it's 5 to the third times 5 to the third times 5 to the third times 5 to the third. So this can be written like this. Now we do something that we just did. This 5 to the third power is right there. This 5 to the third power is right there. This 5 to the third power is right here. And this 5 to the third power is right there. So you could look at it like this, if it helps. But in this case, the parentheses don't really mean anything because everything's being multiplied. So we can actually lump it all together. So tell me, how do we get that? Where does the 12 come from? Only 2 people see where the 12 comes from. Catalina, where does the 12 come from?
Adding all the 5 that are remaining.
Adding all the 5s, that would be 5 plus 5 plus 5 plus 5.
Not like that. Like 1 5, 2 5, 3 5.
Okay, I get the idea, Amir.
Multiply the exponents.
I understand that, but I'm now saying, forget about that, and I'm saying, let's look at this. How do we get to 12? You what?
Add 5, like that.
You add 5s, 5 plus 5 plus 5 plus 5 plus 5 plus 5, because that doesn't equal 5 to the 12, that equals something else. So I understand what you're trying to say, but you're using the wrong words. And so communication is breaking down because you're misleading me. Aman? I'm sorry? There are 12 5s. The word that Catalina and Amir were trying to say was count the number of 5s, not add the number of 5s. You're counting the number of 5s. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are 12 5s here. And so that's what an exponent means. So now we did this, right? But now look. We can now skip all of this and all of this, because if you see that you multiply the exponents, you get the 12 like you did here. So the whole point was to have this very efficient shortcut that we can use anytime we have power of a power. Does anyone have any questions about that? That's not true. You haven't seen anything yet, so I understand your hesitance and I understand you want it to be clear. Wait till we explore some and then it'll become more clear. If you're still not sure at the end, you let me know again, okay? Write down an example of what you're talking about right now on the side of your paper, and then we'll bring it up again in about 20 minutes, okay? So, the last. If I haven't confused you yet, I'm pretty sure I will now, because now we have power of a product property. Power of a product. The first one was product of a power. The The second one was power of a power, and now it's power of a product. Well, guess what? It's all the same words, but the different order makes a difference. Power of a product. Now we have a multiplication problem that's being brought to a power. To find the power of a product, find the power of each factor. So what am I talking about? I'm talking about this. We have a multiplication problem. A times B, that's a product. And that whole expression is being brought to this power out here. So I'm going to say something, and you got to make sure you listen carefully to what I'm saying so that you don't miscommunicate later on. This is similar to, but it is not. But it is similar to, but it is not the distributive property, but it is similar to it. The distributive property is when we do this. And we go like that, you multiply and multiply. But distributive property has this plus sign in the middle. And when you have something multiplied times an addition problem, you multiply times each of the addends. So this is similar to it because we apply the power to each of the factors. So that gets brought to there, and that gets brought to there. And so we can rewrite the expression as a to the m times b to the m. So here's a concrete example. 5 times 6 to the third power. Will mean that we take the 3 and it gets applied to the 5, and we take the 3 and we apply it to the 6, and rewrite the whole expression as 5 to the third times 6 to the third. Okay, so that's what we're going to do right now. So what's 5 times 6, Catalina? Okay, so this really says 30 to the third power. And this says 5 to the third power times 6 to the third power. So I would like everybody over here to use your calculator and do 30 to the third power. I would like everybody over here, you already know what 5 to the third power is, right? What's 5 to the third power? 125. So now you need to figure out what 6 to the third power is and multiply it times 125. And let's see if it works. So, what does 30 to the third power come out to? Laurel, what'd you get? You get 27,000. There's no way 125 times 216 equals 27,000. Yasmin, what do you think? It does? 125 times 216. Oh, look at that. It equals exactly 27,000. So we have proven that it works by this statement right here. So we can see that no matter how you write it, if you write it like this, then it will equal this value. If you write it like this, it equals this value. So we've proven that it works. So power of a product, you take the power, the exponent, and apply it to each of the factors. Does anyone have any questions? So now you've got all of this floating around your brain. These different properties, which sound the same, they function in a similar way. So now we're going to explore different examples of each of them and try to get a better handle on what's actually going on. And I promise you that with a little perseverance and a little time is actually the most important, it will make sense. So let's go ahead and just focus on the product of powers. That's the first property that we discussed. Now, if I did not know, or we did not know the product of powers property, we could look at 4 to the third power times 4 to the fifth power and figure out how to write it as a power by simply just using logic. 4 to the third power is 4 times 4 times 4. 4 to the fifth power is 4 times 4 times 4 times 4 times 4. And then there's this multiplication symbol in between them. And now do what Amani said earlier. Count the number of 4s. 1, 2, 3, 4, 5, 6, 7, 8. So this will be 4 to the 8th power. We can use logic to do that. But now we don't have to. Because now we know the product of powers property. And the product of powers property says that a shortcut to that result is just look at the exponents and add them together. But you have to check and make sure the circumstances are correct. First, is it a product? Yes, it is. Second, do they have the same base? Yes, they do. Now you can write it using the power. Using the property. 4 to the third times 4 to the fifth will be 4 to the 3 plus 5. But we don't need to write that because we can do that mentally. And so it's 4 to the 8th power. Does anyone have any comments? Okay, what about part B? Give me a thumbs up if you think you already know what part B will be. Tyler, what do you think it's going to be? You think it's going to be y to the 15th? Paige, do you agree with that? Think it's going to be y to the 15th? So all we have to do is check. Is it a multiplication problem? Yep, it's a product. And do they have the same base? Yes, they do. So you add the exponents. So Tyler and Paige were correct. It's going to be y to the 15th power. Anyone have any concerns about that? All right, now I want to do something for a moment. What if I took this and erased it and changed it to x? What do you think would happen now? What do you think? We'll start with Yasmin, Chanel, and then Cheyenne. What do you think, Yasmin? Okay, what do you think, Chanel? Same thing? So you think it's going to be yx to the 15th power. So you still add them together, but you put the x and the y next to each other. Okay, I can see that. But now go back to the property itself. What was one of the key words in the property that I highlighted that was really important? You done? Same base. And so it only applies if they have the same base. So what Yasmin said was spot on. In this case, here, it would be only these two together. Y to the 9th, then you would just leave x to the 6th, and so this is what it would look like. Y to the 9th, x to the 6th, and that's it. You can't do anything because they don't have the same base. So I appreciate what Cheyenne offered, that maybe you put them together. She was trying to work it out, and that's great. But the reality is that if they don't have the same base, you cannot do anything with them. Okay? Any questions about that? Any concerns? Okay, so let's take things a step further. Go ahead, try C. Give me a thumbs up when you've got something. Okay, good. Good. Gary, what'd you put? 6 to the 3rd power. Okay. Adriana, what'd you put?
6 to the 5th power.
You agree, it's 6 to the 3rd power. Tristan, what'd you put? 36 to the 2nd power. Okay. Amir, what did you put?
36 to the 2nd power.
Okay, so we have agreement here. David? 6 to the third power. Okay, so now we're going back to that. I'm sorry? Okay, thank you. Michael? 6 to the third power. Well, let me see. Maybe this will help. What if I put that right there? Would that change it for you? Would it make it easier to do? Why did I put that there? Should I put that there? Michael, should I put that there? You gotta speak nice and loud. It is? How do you know? It wasn't there. Okay, so what he's basically saying is that if there's no power, there is a power. It's the power of 1. So now that you see it like this, what do you think? Tristan, what do you think now?
Well, I think it's the same answer.
You still think it's 36 to the...
I think it doesn't really matter which one it is.
Doesn't matter which way it is? Well, look at part A.
It has the same base, doesn't it?
It does. So you see the 4 and the 4, and the result was a... So did the base change?
Yes. No.
4, 4, 4. Y. 6, 6. What do you think the base should be? Okay, so you changed the base, and I understand why. So don't get frustrated, but I'm just trying to point out that the base is going to stay the same, and we add the exponent. So of course it's going to be 6 to the third, and so I put this in to illustrate the fact that there are certain things that you have to know. You have to know what Michael said, that it's just understood that there is a power there. What about part D? Go ahead, give part D a shot on your own. Some people are catching on, some people not yet. That's fine. Doesn't matter. Just give me a thumbs up if you think you've got an answer for part D. Okay, Marcus, what'd you put? Okay, Amani, what'd you put? Okay, so we have two different proposals. -3 to the 8th power, and you say 9 to the... Okay. So what do you think, Kaylee? -3, that's what you said, right? -3 to the 8th power. Okay. Alex, what do you say? 9 to the 7th power. So you agree there. Okay. Yadesh? Which was, again, going back to Marcus's. Okay. Tristan, what do you think this time? Say it again. +3 to the 8th power. Okay. So let's think about the logic again, and let's talk about these parentheses. What is going on in between the parentheses? What's going on there? Cheyenne? So there is actually a multiplication dot there. You just don't have it written out, right? So we can see the connection between this one, this one, this one, and this one. They all have multiplication dots, but that one wasn't written. And then there's something else missing. What else is something that's supposed to be there that's not written, but you're supposed to know? You know? So this has an exponent of 1. Does that change your opinion now? Marcus, how are you feeling about your result? Yeah, you should, because it's exactly right. The bases are the same. Again, I want you to see the connection. Base, base, same base. Base, base, same base. Base, base, same base. Now all of a sudden people are now multiplying them together. And I understand why, because your brain is saying, oh, I like -3 times -3, I want to make that a 9. But that's not what we're doing right now. We're not multiplying it out, we're trying to rewrite it using a power. So this will be -3 to the 8th power. So it doesn't matter if you got it right or wrong initially. This is not a test. This is not a quiz. This is a learning process. I don't care if you don't get it yet, but you will. Yes?
What I mean, like, the positive, because, like, remember at the beginning of the lesson, you said -3 without the parentheses comes out to like...
Yeah, but I said we're not going to worry about that now. So I appreciate that you were trying to understand that, but we're not going to worry about that right now. Okay? I see why you said that, though. Does anyone have any other comments or questions? Good, so let's see how you do on your own with the first property. You got 2 questions. You got a minute and a half on the clock. 45 seconds per. All right, make sure you know your new number, and let's see how we did. Part A, what did you get? I've got students 7, 21, and 6. Student number 7, what do you say?
-4 to the next power.
Student number 21, what do you say?
-4 to the next power.
Student number 6, what do you say?
-4 to the next.
So you all think that it is -4 to the 9th power. That's good. What about part B? What do you say? Student number 13, 2, and 10. Student number 13, what do you say? Student number 2, what do you say? Student number 10, what do you say? It is W to the 14th power. Does anyone have any comments, questions, concerns, issues? Any observations? Any thoughts? Any theories? Good. 1 property down, 2 to go. Yes? We're going to deal with negative exponents next time. Very good question. Too much to do in one day. So, example 2, my favorite property, power of a power. What'd you say, 3D? Okay. So, power of a power. Again, we could do this the long way. I don't expect you to write this, but I just want to quickly show you what's actually happening. We just figured out, with Chanel's help, that whatever is inside here, we have to say 5 times. So we have to say 7 to the 3rd times 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 7 to the 3rd. So we said it 5 times. And now 7 to the 3rd really means 7 times 7 times 7, and that one means 7 times 7 times 7. So we could do it that way, and now I could count and say, okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So this would be 7 to the 15th power. We could do that. I could ask you to do that. Or we could just say, oh, let's use Mr. Gallup's favorite property of all time. Power of a power says if you have a power brought to another power, multiply the exponents. And so 3 times 5 is, wow. Whew, that's a lot easier. Anyone have any concerns or questions? Good, go ahead and write the answer to part B on your paper. Let's see if you can get it. You got 30 seconds. It's not a checkpoint, so it doesn't matter if you get it right or wrong. Give me a thumbs up when you've got it. Oh my goodness, everyone's got it. Isabella, what is it? X to the 10th power, of course. Power of a power. Multiply the powers together. Now let me ask you something. I've been doing this for a long time, and I see a lot of mistakes that students make. Let's pretend that that's on a quiz, and that a student got it wrong. What do you think their wrong answer would be? Tyler, what do you think the most common wrong answer would be for that? X to the
7th power.
Yeah, I'd agree. And so why is that wrong? What did the student do to make that incorrect? I mean, I know Tyler knows, but what else can you say, Laurel? Adding the exponents when you were supposed to multiply. This is incorrect. They added when you're supposed to multiply. So now it's a matter of, okay, I got to keep this all straight in my head. That's part of your job. Anyone have any questions? All right, so let's take it a step further to make sure we see some things that are a little less common but are important nonetheless. Brackets. Brackets are the same thing as parentheses. We use brackets often so that we don't have a double parentheses and it looks a little strange. So what we do is we use a bracket to differentiate it so it's easier for your eye and your brain to interpret. But what if I changed it? What if just for a moment I took this out and I did what I did earlier? You can still leave the bracket there. And what if I put an X? So what would the result be if that was the problem I asked you to simplify? What would it be, Kaylee? X to the 12th. So now it is whatever is here is the base, right? Whatever is there is the base. So now let me put back what really was there. That was there. So that is the base. This is the base, and what I've been trying to get across to Tristan is whatever the base is, it's going to stay the base if you're rewriting it. So it's going to stay the base. This is the base. Now, multiply the exponents. Negative 2 to the 12th power. Does anyone have any questions about that? Last one, a very unusual case that I want to make sure you're clear on, is that all of these properties that we're studying today involve multiplication. This has subtraction. And so the properties do not apply to that, but they do apply to this whole thing. Right here is now the base. Let me say it again a different way. That was a mistake. If I whited this out, and in its place I put an X, what would the result be? Gary? X to the 24th power. So what he is saying is whatever the base is here, you leave the base alone. So now if I put back what was there, that's the base. So let's rewrite that. The base is b minus 1. Now do what he said. Multiply and you get this. So I want to be clear that this is not correct. B to the 24th minus 1 to the 24th is not how it works, because you cannot do that because of this subtraction sign. This would be incorrect. You'll learn more about how to deal with this later on. Giant.
I mean, I know it's new, but when it says b minus 1 and then the 6 on the outside, wouldn't somebody be wrong if they distributed the 6 to both?
Exactly. So I've seen students, and I'm telling you, this is a really common one. Students go, oh, I get it, Mr. Gowan, I do that, and I do that, and it's b to the 6th minus 1 to the 6th, and then I bring it to the 4th power, and I do that, and I do that. Right, that's going to get you this result down here, which is incorrect. You cannot do that because of that subtraction sign. Okay? So that's a very good point. I love how you said that. Any questions, other questions, comments? All right, second property. Now I'm testing your knowledge. You got 2 questions. You got a minute and a half. Let's see how you do. All right, let's see how we did with power of a power. Student 20, student number 9, and student number 22. What'd you get for part A? Student number 20.
Okay, I got D to the 20.
Okay, student number 9, what'd you get? Student number 22, what'd you get? D to the 20th power. What about part B? Students 13, 5, and 4. Student number 13, what'd you get? Student number 5, what'd you get? Student number 4, what'd you get? W plus 2 in parentheses to the 60th power. Anyone have any questions about power of a power? Yep, a little bit. Any concerns? 2 properties down, 1 more to go, and we're going to start wrapping it all together, all in this next example. So now is where your brain's going to start getting fried. Here we go. Power of a product. Power of a product. So, part A, 2DEF. Now, you already wrote down the example, and so I don't need you to erase it or do anything, but from now on, you're going to do something when you write down a question. You are going to put in multiplication dots anywhere there is supposed to be multiplication, and there is a very, very good reason that you're going to see in a few minutes. So, multiplication dots. So this is really what it says. 2 times D times E times F to the 7th power. So you can go ahead and rewrite it this one time, but next time don't write it twice, just write it one time with the multiplication dots. And remember that I am not setting you up for average performance. I am trying to set you up for the highest level performance. And this is the kind of technique that will make sure of that. And what power of a product says is similar to the distributive property. It's not distributive property, so don't say that, but it's like it. That is going to get applied there, 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 and there. Each factor, that's a factor, that's a factor, that's a factor, and that's a factor. Each factor gets the exponent. So we'll rewrite 2 to the 7th times D to the 7th times E to the 7th times F to the 7th. And when you write it as a final answer, you don't put the multiplication dots. I'm not going to freak out if you do. But best practice is you just write this. That's the best way to write it. Does anyone have any questions on power of a product?
Is there any case where like a student would like say that the 2,7, D7, E7, F7 would be like something that they could add the exponents to? That,
Absolutely. And so why can't you? But the question is, you said,
Oh, yeah.
would we see a student who messes up and does this? Who writes 2 D, E, F to the 28th power? Would we see that? Would I see that as a teacher? Absolutely. So the question is, why can't you do that? Why can't you put that all together? Gary, and why can't you do it?
Because they have different bases.
They don't have the same base. You can only do that if they have the same base. That's the key right there. So that was an awesome question and an awesome thought. Very important. Does anyone have any comments or questions? So now part B is actually a little bit different, but I brought it in because it's a good time to show you that this is not a product. This is not a product, but you should know at this point that multiplication and division usually get lumped together. And so the property works for a division problem as well. This will get applied to the top and will get applied to the bottom. And so we would rewrite this as a to the 5th power over b to the 5th power. And that is simplest form, or that is applying the property. Does anyone have any questions about that? So I'll be quite honest with you. All we've done is lay down the foundation. We haven't even really done anything yet. Now we're going to do it. Now we're going to take everything and learn how to apply it to a scenario. Okay? It's going to be a little confusing to start with, but it will start to make sense over time. So let's take a look at part C. Don't worry about part D yet. So when I did the first example, you didn't really have to worry about anything because you knew we were only going to be working on one property. And then I did the second example, and you didn't have to worry about anything because you knew we were focused on one property. And the same thing for the first two parts of this example. But now, all of the properties are going to apply. So the question is, where do you start? And that's the first thing. You start on the outside and work your way in. You need to train your eyes to look at the outermost exponent. This exponent is furthest on the outside. That's going to get dealt with first. Yes?
So you kind of work on it like a puzzle?
Absolutely. That's one reason why, again, I'm not a lover of math, but I do find certain aspects of math interesting because there's so many parts of algebra that are like puzzles. And this is a perfect example of it. There's more than one way to figure it out. This one, probably the one way, maybe a few other ways to do it, but really there's one way to do it. But you're going to start seeing examples where there's a bunch of different ways to do it, and it's one thing for you to do is figure out the way that makes sense to you or what's the most efficient. But no matter what, often we're going to start furthest on the outside. And so this exponent is getting applied to this whole thing. But think about what technique I taught you to do. You should not have written this down like this. You should have written this. 4 times x to the 3rd times y to the 6th power. And here's why. Students, young people, older people, it doesn't matter, very often take the 4 and attach it to whatever letter is next to it. But you have to understand that the 4 is a factor, x to the 3rd is a factor, and y is a factor. There's 3 different factors. So we have to apply the exponent to this factor, to that factor, and to that one. It's going to come here, it's going to go here, and it's going to go here. So let's start with the 4. 4 to the 6th power, that's no big deal. Here's where it becomes a big deal. we have x to the third power being brought to the sixth power. What property is now happening? X to the third to the sixth. I'll give you a hint. It's my favorite one. Tyler?
Power of power.
Thank you. I appreciate that. Power of a power. So x to the third to the sixth, this is the base now. So we've got x to the third being brought to the sixth power. So you have to be careful about that. That's where things get a little tricky. Then we have y to the sixth power. That's not tricky at all. So now we have to take it one step further and actually execute the power of a power right here. My really advanced students will start learning how to do it all in one step. That's for my super high level advanced students. Most of us need to do them one at a time. But no matter what, you will get to the end result. 4 to the 6th power is going to stay. Now we need to do x to the third to the 6th. What's that going to turn into? What's it going to turn into? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 confident people. Amir, what do you think? Michael, do you agree? Yeah, it's going to be x to the 18th because power of a power says you multiply the exponents. And then y to the 6th. Does anyone have any questions about that? So it can get tricky. But if you just pay attention, pace yourself, pay attention to the details, you will see, like in part D, it's more of the same. Start on the outside. This exponent's going to get applied to everything. But to make sure we don't mess up, when you write down the original expression, put the multiplication dots in there so that you see that they're all separate factors. And this is going to get applied here, here, and here. So this becomes a base, x to the third, being brought to that third power, times, now this is a base, y to the second, being brought to that power. And this is a base, z to the fifth, being brought to that power. Now utilize my favorite property. X to the third to the third. What will that become? Yadesh? X to the ninth. And what about y to the second to the third? What will that become? Yasmin? Y to the sixth. And what about z to the fifth to the third? What will that be, Cheyenne? Z to the 15th. And that is now. Anyone have any concerns or questions? Any comments? Any issues? Okay, so that was the learning process. Let's see how you do on your own. Checkpoint number 3. I'm going to be cruel and I'm going to give you a minute and a half. Push yourself. My super high level students, try to do some things mentally without making mistakes. All right, stay on your toes. Make sure you know your number. Here we go. What did you get for part A? I've got student number 1, student number 7, and student number 10. Student number 1, what'd you get?
B to the 10 times C to the 5th times D to the 22.
Okay, student number 7, what'd you get? Which I think is what she said. Student number 10?
B to the 10, C to the 5th.
Part B, what did you get? Students 6, 9, and 14. Student number 6, what'd you get?
10 to the 6th times W times 60.
Okay, student number 9, what'd you get? Which I think is what Kaylee said. And student number 14?
10 to the 6th times W times 60.
Nicely done. Any questions or concerns? Go.
Is it still probably going to multiply by? Because I see them put the multiplication stuff.
Right, it's still multiplied. So this is b to the 10th times c to the 5th times d to the 25th. It is very common to not even say those words and just say b to the 10th, c to the 5th, d to the 25th. You can say it like that, but you have to know in your brain that that's actually being multiplied. Is that what you're pointing out?
Yeah.
Okay. Any other comments, questions, any observations, any thoughts? Good. Your homework is in the old workbook, page 82. You're going to do numbers 13 through 27, which is a total of 15 questions. And you are to do them all tonight. We are not waiting till the end of part 2. It is all inclusive. And typing practice, you need to keep that going. And you will have a quiz next week. I will tell you more about it at the end of this week.